Now we are going to explain the construction and working of a half-wave rectifier circuit. So in half-wave rectifier, only one half of the AC input voltage will be permitted to flow through the circuit. So through the output of this circuit, only one half of the voltage will be permitted. Okay, let us see the construction of the circuit of a half-wave rectifier, students. This is the circuit which consists of a transformer. Preferably it is a step-down transformer in most applications, so that the number of turns in the secondary winding of the transformer must be less than that the number of windings in the primary. So this is the primary of the transformer, and this is the secondary coil of the transformer, and this is the central core of the transformer. So now this is a step-down transformer whose input or the primary terminals are connected to the input voltage of 220 volt AC. This is the AC voltage. So this is a 220 volt RMS voltage, and its frequency is how many cycles per second is 50 cycles per second. That is why frequency is 50 hertz. Okay, now we are going to convert such a 220 volt AC voltage into, say for example, 12 volt DC. For example, 12 volt DC I have to convert. So for that, first of all, we have to step down the voltage of 220 volt AC into 12 volt AC first of all. Okay, students? That means the high AC voltage must be first converted into low AC voltage. So for that purpose only the transformer is being used. So transformer is used to step down 220 volt AC into 12 volt DC, for example I said. Okay students, for example. So in general, what will be the voltage available across the secondary terminals of the transformer? It is denoted as Vs. Okay students. So Vs denotes the secondary voltage of the transformer. And you must definitely remember that this voltage appearing at the secondary is still in AC only. It is not DC voltage. We have not converted still. What we have done using the step down transformer is only we have lowered the 220 volt AC into 12 volt or any desired volt in AC only. So the secondary voltage is still in AC form only. Okay. Now you see here the two secondary terminals are denoted as A and B. A is connected to a semiconductor diode P region, and the other end B of the secondary of the transformer is connected to the N region through a output resistance which is called as load resistance. Okay students? So the secondary terminal A of the transformer is connected to the P region of the diode, and the N region of the diode is in contact with the secondary terminal B of the transformer, which is in series with the output resistance which is called as load resistance. So why this is called the load resistance? Because across this resistance only we will get the output voltage called the DC voltage, or the output power will be available across this resistor. Therefore it is called as the load resistor. Okay students, have you all understood the circuit? So I told you the circuit consists of a step down transformer preferably, and the two terminals of the secondary terminals of the transformer are connected, one each to the P region of the diode and the N region of the diode in series with the resistor. Okay. So the output voltage which is a DC voltage is available only across this load resistance. So I connect two wires across this load resistance. So between these two terminals only we get V output. Okay, V output, which is nothing but the DC voltage. Okay students. So the output voltage is available across the load resistance. Now in the CBSE textbooks and some textbooks in the circuit they have not connected the load resistance to a ground terminal. But in some other competitive exams and some other state board books and all, if you see the circuit means you see that this output resistance is connected to a ground. Okay, students? So this terminal is called the ground terminal. Ground terminal means what? 0 volt. Okay, students? This is a 0 volt terminal. Okay, this is a 0 volt terminal. This grounding, whether it is required or not, you need not take it seriously at all, because this grounding is not compulsory. Even if you don't ground this resistor also, you will get the necessary DC voltage at the correct level. Suppose if you don't ground means what may happen? Across this resistor, output DC voltage is available, and the output DC voltage will have a certain minimum value that will be fluctuating sometimes. So to avoid the fluctuations in the lower limit of the output voltage, this grounding is used. Otherwise, it is not compulsory. Okay, students? Now, I have grounded, for example. So the output voltage is available across the load resistance. So this is a description of the circuit construction. Have you all understood? Now we are going to the working of the rectifier. Okay, students? Why this is called as a half wave rectifier? This is because when you apply this input AC voltage, it is having two half cycles, the positive half cycle and the negative half cycle. This is represented here in the input voltage waveform. This is the waveform corresponding to the input voltage AC, which is applied to the primary terminals of the transformer. So how does the voltage vary? You can see very clearly at different intervals of time, t equal to 0, t by 2, t, 3t by 2, 2t. You can see the voltage is varying. Okay, students? So it is proportionately varying across the secondary also. So this waveform is the same. The waveform is the same corresponding to the primary as well as the secondary terminals, provided the magnitude of the input voltage is 220 volt and the magnitude of the secondary voltage is lesser than 220, say for example 12 volt, I said. So these are the voltage variations corresponding to the input voltage, which is the AC voltage. And I said only the positive half cycles. So this is the positive half cycle, this is negative half cycle. And next is third half cycle is positive, fourth half cycle is negative. So alternately all the odd number of cycles are called as positive half cycles, and the even number of half cycles are called as the negative half cycles. And only one half cycle of the AC input is permitted. That is why it is called as a half wave rectifier. Okay, students. Now let us explain the working of the rectifier. Now the working of the rectifier you divide into two columns or two separate headings. Okay. So during the first half. Okay, students. So this is the first half cycle. This is during the first half cycle means what? During the positive half cycle. So input is positive. Okay, when the input is positive. Now this is a fluctuating voltage. Already we have studied there is no fixed positive and negative. Is it not? The positive and negative goes on changing. Okay, students. So according to the 50 Hertz frequency, depending upon the frequency, the voltage will be positive for some instant and negative for some instant of time. But at a particular instant of time, you say for example this A is positive and this B is negative. Okay. So when alternately the voltage is changing positive, negative like that, at a particular instant of time, say the secondary terminal A is positive such that the B terminal is negative. Okay, students. When this situation occurs, when the P region of the diode is connected to the positive of the input and N region of the diode is connected to the negative of the input voltage, now the diode will be forward biased. That is very important. So during the positive half cycle, the PN diode will be forward biased. Okay, students, diode is forward biased. Now we have studied in the previous topics what is meant by forward bias. So when P to positive and N to negative means the diode is said to be forward biased. And what happens during the forward bias also I have taught you in the previous class. During the forward bias, the depletion region width inside the diode decreases. So the depletion region decreases means the resistance offered by the diode to the current decreases. So the diode offers less resistance. Diode offers less resistance to current. Okay, students, this is very important. This is because of the shrinking of the width of the depletion region. So if it offers a low resistance means it will permit the current to flow. Okay, students, so diode, okay, permits current. Diode permits the current flow. So the diode conducts current. Diode conducts the current. As a result, what will happen? Through the diode here, a current is flowing, say load current. I will call it as load current. So when some current is flowing through this resistance, the product of current and resistance will be equal to the voltage. Is it not? So a potential is dropped across the external resistance called the load resistance. And that voltage only is called as the output voltage. And this voltage we are going to rename as a DC voltage due to the reason that always it is going to flow in the same direction. Now you tell me, in which direction does the current flow? Is it upward or downward through the resistance as per this diagram? It is in the downward direction. Okay, students? So it is measured with respect to the ground. Output voltage is measured with respect to the ground. So this is happening during the first half cycle of the AC input. Okay. Now what will happen during the second half cycle? Okay. During the second half cycle. So which portion of the input is going to flow through the diode is the negative. Okay. The negative input, I will say the negative half cycle of the input voltage. So this is the first half cycle. And this will be the second half cycle. So this portion corresponds to negative part of the AC input voltage. So what will happen at a particular instant of time? Say now A is negative during the second half cycle and the B is now positive. Okay, students? Okay. Now you see that the P region of the diode is connected to the negative voltage and N region is connected to the positive of the input voltage. So this is the condition for what type of biasing? It is reverse biasing condition. Is it not? So when P is connected to the negative and N is connected to the positive means the PN diode will be reverse biased. So I will write here PN diode is reverse biased. Okay, students. So when the diode is reverse biased means what will happen? The internal potential barrier or the width of the depletion region will expand in size. It will expand in size. So the width of the depletion region is a measurement of the electrical resistance, is it not? So when the width of the depletion region increases means what will happen to the resistance offered by the diode? It will also increase. So it offers a high resistance. So diode offers high resistance. Okay, students, it offers a high resistance. So when it offers a high resistance means naturally conduction will decrease. So diode does not conduct. So diode does not conduct. So there is no current flow. There is no current flow which is along the load resistance. So there is no current means IR product will be equal to 0. There is no output voltage across the resistance. So one full cycle is now over. What should happen next? You can guess now. The third half cycle. So what should be the polarity of the third half cycle? It is positive once again. So during the third half cycle, which is also a positive half cycle, what will happen? The diode will be forward biased and it will offer a low resistance to the current. As a result, the diode will permit the current flow. Diode will permit the flow of current. What next in the fourth half cycle? It will be the repetition of the same 2 cycles again and again. Have you all understood, students? So from this, what do we come to understand is, during all the positive half cycles, the current is permitted to flow through the diode. So only the positive half cycles are permitted and the negative half cycles are stopped. So this type of rectification of the AC input into unidirectional output by allowing only one half of the AC input is called half wave rectifier. Okay, students? Okay, now this is the output DC voltage, is it not? Now I am going to draw the graphical representation of the output DC voltage. So here you see here, my dear students, this is the output voltage which is DC. Okay. So if I will draw the graphical representation, means the positive first half cycle is permitted, is it not? So the first half cycle is permitted. The second half cycle is not permitted. Again the third half cycle is permitted. You see, the third half cycle is permitted. Understand? And the fourth half cycle is not permitted. So now you will see that only the positive half cycles are permitted. Okay. So one half of the AC input only is rectified, and hence it is called as what? Half wave rectifier. Okay. Now based on this, I will write one efficiency of the rectifier. Okay, efficiency. Already we have taught this in the regular class in the chapter alternating current and electromagnetic induction chapter. Efficiency of a transformer we have studied. Is it not? Output by input power. Like that here also, efficiency. Okay, the same symbol I am going to take. So this is equal to the DC output. Okay, DC output power. DC output power divided by the AC input power. Okay, students. So, how will you define the efficiency of a rectifier? The efficiency of a rectifier is defined as the ratio of the DC output power to the AC input power. So that you find that for a half wave rectifier, this is found to be equal to 40.6%. 40.6%, which is considered to be low only. Which is considered to be very low only. Okay, now I will tell you where these rectifiers are used. Okay, students, where these rectifiers are used. See the application number 1. It is used in, okay, it is used in low power, okay, low power charging units, wherever low power charging units, okay, students, and it is used to produce, voltage pulses, where we are using this voltage pulses in electronics. You are going to study in the future topics in electronics. See, for radio communication, television communication, construction of logic gates and all, we need square waves. Here we are dealing with only sine waves, sinusoidal waves. But the input voltage can be in the form of a square, rectangle, triangle, sawtooth waves. All these can be generated. Okay, for that voltage generating circuits, this half-wave rectifier circuits can be used. And one more major application, my dear students, that is used in radio broadcasting. See, in the radio stations in front of the mic, okay, they are reading the news. News reader will be reading the news, and that sound is modulated and transmitted in the sky. But the radio set in our house is again what? Reproducing the original voice. That is called as a demodulation. So this rectifier is used in demodulation. You are going to study in the last chapter communication physics. Okay, students? So it is used, okay, in demodulation circuits. Okay. So demodulation circuit to recover the original voice signal, it is used. Okay. Now in all these applications, what is the very frequently used application in our home. Do we use a cell phone charger or not? Cell phone charger. You see here how to charge the cell phone and all we are using. We call this as what? Cell phone charger or adapter. Okay, my dear students. So in this adapter, what is present? You must know. This is called as adapter or cell phone charger. Inside this, compulsorily there is a rectifier circuit. Understand, students? There is a step down transformer. Okay, and it is connected to diode. But what type of rectifier circuit is used here? For low power charges only half wave rectifier is sufficient. But actually inside this we are using bridge rectifier. We are going to study in the next subsequent topic. So bridge rectifier and also filter circuit is there. Okay. So this will give you a constant voltage of 5 volt or 6 volt. 1.6 ampere. Understand, students? So this is the summary of this half-wave rectifier, students. So what is a half-wave rectifier? It is a circuit which rectifies only one half of the AC input voltage. So it is using how many diodes? Only one diode is used. So on what principle this rectifier is working? Whenever a diode is forward biased, it will allow the current to flow. Whenever a diode is reverse biased, it will not allow the current to flow through it. So this is the principle of working of any rectifier, not only the half-wave rectifier. So in first half cycle we have said that only the positive of the AC input voltage is permitted. Okay, and the diode is forward biased. It offers a low resistance to the current and hence it is conducted, and output voltage is available across the load resistance. During the second half cycle, when the input voltage is negative with respect to the secondary, so the diode does not conduct because it is reverse biased. It offers high resistance to the flow of current. So such a rectifier which allows always only the positive half cycles of the AC input is called as a half-wave rectifier, and its efficiency is only 40.6%. So we are going to construct another type of rectifier called as a full-wave rectifier. I hope you must have understood. Be ready for the full-wave rectifier.